This is the question in front of you, as you can see. So a transformer with toroidal core of permeability mu is shown in the figure. Assuming uniform flux density across the circular cross section of radius r very less comparatively than capital R, and neglecting any leakage flux, the best estimate of for the mean radius r is. So this, you can see, this is the question where Vp is equal to V cos omega t. It can be seen Ip is equal to I sin omega t, and P small r capital R Is is equal to 0, Ns is equal to this thing Vs is equal to. Now you have to go for this question. So how do we go about these questions? As you have earlier also seen in my previous discussion, what we have done is that we have related the flux equation with the equation of your mmf and reluctance. Similarly here also, if we have to go about this question, same phenomena we will be using, that is that we will be relating our flux phenomena with respect to our reluctance. So here is the question. Again, you can read the question once you can see the question. Now we'll move to the solution part. So let's see how to go for the solution part. Here you can see my reluctance is equal to LC by MA, where my M is the permeability of the material, A is the area of the cross section, and LC is the length of the circular cross section. So the entire length of this cross section would be 2 pi r, whereas the area of this section would be pi r square. So my reluctance would be given, so here my reluctance would be given as 2 pi r into mu into pi r square. So from there what we got, pi and pi gets cancelled, so this we are left with 2r and mu r square. This is for the reluctance. Now we got the value of reluctance in terms of this. So the value of resistance, if you want from here, resistance would be reluctance divided by 2. Okay, reluctance divided by 2, and this mu r square will go on top, mu r square. So one thing was this. Now because my reluctance is what, essentially reluctance is my mmf by flux, because mmf is what, mmf is voltage and flux is current. So voltage is equal to I into R. So your mmf F is equal to flux into your reluctance. So your mmf by reluctance is equal to your flux. So from this part of the equation here, same value we have derived here. Now once you get the value of this, now you want the value of your flux. So how do you calculate the value of your flux? In order to calculate the value of your flux, so what we do is we have our basically the flux can be expressed in terms of voltage, and that would be your flux is equal to minus 1 by np integral 0 to t e dt. So here you can see the value, if it's like in this direction, so this happens to be minus. So again we will move this point of flux to here, and let's see how can we represent. Your flux is equal to minus 1 by np 0 to t e dt, instead of e minus vp by dt. So this minus will go, and here we are left with 1 by np, and instead of vp we can write vp is equal to v cos omega t 0 to t v cos omega t. So after differentiating this term, so we get the value after differentiation. So let's rub over here till here we are there. Let's rub over here after differentiating this term. So what value we get, since my vp was equal to minus e, so once I differentiate this flux, I get the value as 1 by np, this is 1 by np 0 to t your integral v cos omega t dt. V value I take outside, v and p, and integration of cos omega t will definitely give me sin omega t divided by omega. So this would be sin omega t by omega. So this is the value of flux over here. So this was the value of the flux. Now what is the value of, for example, if you need the value of your uh, total reluctance. So reluctance, we saw reluctance value was resistance value which is needed, R value is needed in terms of this. So R is equal to reluctance divided by 2 mu R square. So essentially what is my reluctance, and what are the other, see, reluctance is basically mmf by flux. So reluctance is my mmf by my flux. So flux value is this, mmf value is ampere turns, np into ip can be expressed as I sin omega t, and this flux can be expressed now v omega np sin omega t. So this sin omega t will get cancelled, and this np will go on top, so it becomes np square. So we will so we can see that my reluctance is equal to np goes on top, it becomes np square, and this omega also goes on top, omega current will remain as it is, I and v divided by v. So this is essentially my reluctance value, that this value I am substituting here, reluctance value. Now once I get this reluctance value from here, let this be equation 2, okay, and let this be equation 1. If I substitute this value here, now let me rub this, if I substitute this value here, so how much I will get? R reluctance value is np square omega into I divided by v, this is reluctance, into 2 down here, into mu into r square. So this is my final value. So if I see the options, I get this final value as r is equal to np square omega I mu r square into 2 pi. So is there any option available with us? Let's see the options. So we have R is D, option D is the answer for this. Here we have the options, you can see. So option D is the answer from this question. So this is how a question is dealt with. It is not very difficult. So hope you understood. Keep following, stay safe.